KINDRA classification. You have 20 minutes and we will
Thank you, Dallas. Yeah, I hope to be able to do it much faster because Marco already covered quite a lot on the classification system. And there will be a few additional slides compared to Marco's, but I think that it's, I would like to spend a bit more time on the trends and gap analysis later, which is actually a lot of new data, while many of you will have seen this before. So just to recap, our purpose, making groundwater visible and accessible and treasured, is we try to do by developing this research classification system, which provide easy access to groundwater research and knowledge classified based on Horizon 2020 plan societal challenges. This is an important part of KINDRA. And then providing easy access to research and knowledge information available in papers, reports, and other resources classified according to the developed classification system in the European Inventory of Groundwater Research, GEUS, which Cliff will tell you more about after this presentation. Using the FAIR principles, this is and compiling information not available elsewhere. And the FAIR principles is something that the EU tried to promote. We also heard about this morning with Johan. And FAIR in this aspect means findable, accessible, interoperable, which also Isabel mentioned, and reusable. So this is what we are trying to do with AGA. We try to provide information which is easy to find and get access to. And then finally, to identify groundwater research trends and gaps, very much related to the implementation of EU policies. So how do we do that? How do we classify European groundwater research and knowledge? And Marco mentioned that we, of course, we have to take into account the societal challenges, health, climate change, etc. Research topics, geology, geography, chemistry, operational actions, mapping, monitoring, modeling. Keywords could be nitrate, quality, quantity issues, some important ones. EU policies, the Water Framework and Groundwater Directive that Elisa presented, and then the type of the resource that we are actually providing metadata for, and the degree of quality insurance for these resources. So it's articles, proceedings, reports, etc. that Marco also presented. So starting with the last one, the quality assurance of the different resources that we upload, we are actually talking in evaluating two main types. Research, which we classify in class 1 and 2. Class 1 is only groundwater, it's only research papers from scientific journals. Class 2 is also includes proceedings, etc. And then knowledge, which is class 3 and 4. And this is actually the main part of the IGA and the main additional value of IGA, because here you find a lot of different reports, could be from authorities, etc., consultants producing reports for authorities, and those type of reports typically have different kinds of quality assurance. Some have a good quality assurance, which would be in class 3, and Some do not really have, or it's unknown to what extent they have been quality assured, and that would be in class 4. And class 1 and 2, we can evaluate by professional tools, which research organizations typically have access to. The most common are Web of Science and Scopus, and we have chosen to use Scopus, as this is a European tool, while Web of Science, it was originally American, but it's bought by the Chinese now. But there I will show a few slides on that to compare how they actually perform. So for class 1 and 2, we primarily look at the Scopus resources, and for class 3 and 4, it's primarily IGA that we are looking at. So how do we relate, define and relate the research categories? And Marco also, it was originally his idea. He was an Italian master of the cubics cube in his younger days. But it's quite nice ways to actually relate the societal challenges, the operational actions, and the research topics, and combine them in these 125 connection points within the cube, which they will produce. And for the societal challenges, actually there are 7 in the Horizon 2020, but we decided on these 5 and combining 6 and 7 in 5, and actually not taking transport into account, which we probably should have, because there are actually also some studies on groundwater transport issues. So but the societal challenges are health, food, energy, climate, environment, and resources, and then policy, innovation, and society. The operational actions, which is what many of us are doing daily, is mapping, monitoring, modeling water supply issues, or water supply and assessment and management. And the research topic, we decided after a lot of discussions on the main natural science disciplines. So biology, chemistry, geography, geology, and physics and mathematics. And this is then again another representation of the cube with the 125 connections between these overall categories, and this is difficult to comprehend. So we slice this cube in different at different points. It could be all the different societal levels, challenges, to get a 2D presentation of the different research areas. We did this here. This is a slice for societal challenge 4, climate, environment, and resources, based on the Scopus resources. And so this is, here we have 63,000 publications, and this is within both class 1 and 2. And this is actually only half of what you can find in Scopus, but these 63,000 publications include a keyword from each of the 3 categories: societal challenges, research topics, and operational actions. And here you can see, actually in contrast to the IGA, that the most popular research area is actually geography and assessment and management. You can find more papers related to groundwater which have the keywords geography and assessment and management than geology and assessment and management. So this also illustrating the bias that we have in IGA, which is populated by geologists, of course. Then for the population of Eiger and for the assessment in Scopus, we need to evaluate a lot of different groundwater research related keywords. And we defined, I don't know exactly the exact number now, it's increasing, but we have more than 200 main keywords in the database which are used in Eiger and also for the following analysis in Scopus, Web of Science, etc. And the keywords were found by looking in the 20 leading groundwater science journals and also make searches in Scopus, Web of Science, Google Scholar, and the EU policy documents. And if you look at the information you get from the research databases, Scopus and Web of Science, you can see here one good reason to select also Scopus, because the database is actually much larger than the Web of Science database, being for the baseline search string here is groundwater or groundwater in 2 words or hydrogeology. From that you get 125,000 publications for the period 1997 to 2016, while only 94,000 in Web of Science. If we include all the keywords that we have in our thesaurus, Eiger thesaurus, we actually get 124,360 publications, indicating that we have actually we cover more than 99% of the publications you can find on Groundwater Research. There are 643 publications which we do not get in this with our keywords, and from those we can then define additional keywords to include in Eiger at a later stage. And this is, I had a look, and part of that is, for instance, keywords related to groundwater ecology, which is an upcoming research area. And here it's an indication of the upper 2 bars from Scopus and Web of Science is the number of Class 1 and 2 publications, and the lower 2 ones that is only Class 1 publications. So that's the research papers. So you can see by far the largest amount of resources in these databases are scientific journal papers that we are analyzing. I think that's it. Yeah.
Thank you very much.